Okay, here we go. Last day. Couple units ago, when we started learning about triangles being congruent, we talked about three transformations that, when applied to triangles, keep them congruent. All right, we talked about three during one of the class days. Those three? Rotations was one. That will not change the size or shape. Followed by reflections. Yep, that will remain congruent. And translations. And I think once we came up with these three, I said, hey, aren't we missing a big transformation up here? And that was dilations. All right, you're right. Dilations don't make triangles congruent, but they do make them similar, which is the unit we are in right now. All right, so why does a dilation make it similar? Well, what is a dilation? It enlarges. Does it have to enlarge? It can get smaller. So enlarges or reduces an object. Here's the big key, proportionally. Proportionally. So the sides, the lengths are still in the same ratio. Now I got a quick question for you, not really honors level, but something to think about. If I enlarge a figure, does that mean the angles get bigger as well? The sides get bigger, but do the angles get bigger? So when I reduce a figure, do the angles get smaller? What happens to them then? Do they? When you enlarge or reduce a figure, they stay the same? Okay, correct. Yes, because the triangles are still what? Similar, and if two triangles are similar, corresponding angles are congruent. All right, so when you dilate, don't just the sides get bigger or smaller, not the angles. They remain the same. Can you do me a favor and just cross out center of dilation? That's something we'll focus on. We do a whole unit dedicated on transformations coming up in Unit 9. We have heard about this word, though, scale factor. I'm going to ask one of you guys to dig deep. What do you remember about a scale factor? 6? Any ideas? Remember anything about a scale? Who's 6? 6? Okay, scale factor. Here you go. Let me give you an example. Scale factor of two objects is 1/2. Now, okay, now we can talk. Go ahead. Well, what's the one in? Okay, that just went way. I didn't think it was going to go with the Eiffel Tower. So what's the 1 and the 2 then? Yeah, I got you that. But what's that telling me? Specifically about your Eiffel Towers. If one Eiffel Tower is 6 inches tall, how tall is the other one? Why? Why not 10? Why not 11? So the scale factor is what? Okay, I'll let you off here. It's the ratio of the corresponding lengths of two similar figures. Got a little Eiffel Tower reference in today. I think we're good. Now, I just want you guys to realize I use this word here, lengths. I could have used sides, but when I say lengths, sometimes you may not know the sides, but maybe you know the altitudes. Those are in the same ratio. What other segments, special segments do I have in a triangle? I got altitudes. Mid segments could be in the same ratio. I have medians could be in the same ratio. Think of a quadrilateral now. Connect the corners. What are those? Diagonals could be in the same ratio, right? So it doesn't necessarily have to be sides, but they do have to correspond to each other. You guys remember back from your middle school days? Anybody remember the symbol for dilation? No, really? Yeah, it's pretty cool. It's a capital D. Yes, it's a capital D for dilation. It usually has with it a subscript. Subscript? Subscript? Down near the bottom? Okay. You will see a value here. That value is the scale factor. Okay. You will see a number there. That value is the scale factor. Okay. So now I kind of want you to put two together now for me. Enlargement. Think about it. What do you think the scale factor would be for an enlargement? What number do you think would be there that says, I know without even looking at a diagram, that's going to be an enlargement? What do you think? Or you can just 3? Yeah, that would be an enlargement. What else? 2? Yep, that's an enlargement. Okay, 4, 1. Okay, thank you. Okay, can we just sum this up then? Anything greater than 1. So an enlargement would be a scale factor that would be greater than 1. All right, what about if it's shrinking? Ooh, you got to clean that up. I'm not going to accept less than 1. Because, hey, surprisingly, that's less than 1, but that's actually an enlargement. And I'll talk more about that later, but so give me an example. A fraction? 3/2 is a fraction, but it's not an enlargement. Okay, we're getting it now. It's got to be between what? 0 and 1. So it's got to be between 0. Your scale factor's got to be in between. And 1. Yes. Negative is a whole different ballgame that we'll get to when we get to the unit. And then usually it's already been taken from me, but usually I get honors level. You don't have 1 represented. What happens when the scale factor is 1? Nothing happens, right? It's still the same object. All right, so let's test our knowledge here. Enlargement, reduction, and then I'm going to have you guys find the scale factor for me. So real quick on number 1, we're going from figure A to figure B. Is that an enlargement or a reduction? 19. Here we go. That is an enlargement. And then what I'd like you guys to find is what's the scale factor now? Which means find 2 lengths that correspond, find them, and then compare them. You shouldn't have to bust out any distance formula here because I believe there's a couple pair you could count the distance of. So find the distance of 2 corresponding lengths. 2 corresponding lengths. And then we'll talk. $14, did you find the length of one of them? Okay, which one's 4 or which one's 5? Which figure? A is 4 and B 5. Okay, I got a question now. You found the 2 corresponding lengths, but is it going to be this or this? Those are 2 different ratios. Hate to break it to you. 4/5 is different than 5/4. Which one is it going to be and why now? Which one is it going to be and why? What did you guys just tell me in part A? It's an enlargement. What do I have to know about my scale factor? It's got to be greater than 1, so which one do I need to accept? 5/4, yep. It's got to be 5/4. Okay, second question. I won't ask anybody and waste time. I know that's a reduction. So knowing it's a reduction now, Come up with the correct scale factor for me. So find the lengths of two corresponding lengths. Find the distance, and then make sure we put it in the correct order now. All right, here we go. Right, what do you got for me? 5. What do you have for the scale factor? 1/3. Quick question. Why didn't you say 3/1? Look at that. It's a reduction. If anybody had 2/6, you can keep it that way. That's fine. But not 6/2. Any questions on finding the scale factor? Charlie?
So if the scale factor is 0, what happens?
There was no dilation. But there's no resulting figure, though. Like, at least with the dilation of 1, I can just create the same figure right on top of each other. So it can't be. I don't think it's possible having a scale factor of 0, because there would be nothing there to do, right? No length, no nothing. And as we always like to do, try to put it on a graph if we can, so we can use our favorite formula. Please do not go ahead, because I'm going to assign people. You guys remember your groups from yesterday? Groups 1, 2, and 3?
Yes.
Yep, because your groups are going to go back to work now in a second. Before I assign some responsibilities to the 3 groups, we know it's a dilation. Verify that it's similarity. All right, so verify that these 2 triangles are actually similar, which would mean in my mind, there's 3 ways we could go about it to prove these 2 triangles similar. What's one way we could try out? 5, again. Side, easy with your tildes, yep. Another method, 20, going deep. Side angle side similarity, and then the other method, 6, angle, everybody's favorite. All right, well, we're on a graph here. Angle going to work out? There's no way I can figure out if those angles are congruent or not. What about side angle side? Why not? Yeah, right there. There's no way I'm going to get that angle. So the only method we really have on the graph is side, side. Little reminder, what do you got to know about the sides? They're in the same ratio. That's what every group's going to do now. You're going to take. I'm going to give you a pair of corresponding sides. You find what ratio they're in, and we'll see if the other 2 groups match it. All right, so group 1, you have BC and EF. BC and EF. Group 2, I will give you AB and DE. And group 3, process of elimination, you have AC and DF. And this is honors, so leave your answers. Simplest radical form if possible. All right, go ahead. I'll give you guys a couple minutes. Make sure you look around at each other. And also, I need the scale factor at the end here for your 2 sides. So be prepared to answer that. What's your scale factor? If your group was not responsible for the following. BC, group 1, what do you have for the length of BC? Simplest radical form? Radical 10. And how about EF? Good. For a scale factor equal to 2? 2? Well, that's my question here. I'm looking at these two you have right here. I'm crossing out the 10s, radical 10s, and I'm seeing 1/2. Why'd you guys say 2 then? Thank you. It is an enlargement. So can I have 1/2 as a scale factor, Nick? No, I got to have the 2. Good. Here we go. AB, group 2, AB. 2 radical 2. Thought I heard a 10 in there. And how about DE? 4 radical 2. Yep. The radical 2's cancel. So what would be my scale factor then? 2 over 1 again. Yep. So we're 2 for 2 here. And group 3, AC. Radical 10 and 2 radical 10. Radical 10s again cancel out. So what's my scale factor? 2. So bonus question. Not only are these triangles similar, but they're also what type? Isosceles. Nice. So we can say, hey, take a look. All the ratios came out to be 2 to 1, 2 to 1, 2 to 1. So we can say that triangle ABC, triangle DEF are similar. Why? By side, side, side similarity. Okay, that's how that works. All the sides were in a ratio of 2 to 1. Questions from you guys? We all good? I believe there's another graphing question tonight, so grab yourself a slice if you need it. Okay, no ghetto graphs, none of this stuff, please. All right, grab yourself a slice if you need it. Behave this weekend.